Hello everyone, good evening. In the previous classes, we have already learned queues implementation using static as well as dynamic method. So right now we will see how to implement a priority queue using both static as well as dynamic implementation. So first let us see what is a priority queue. So we already know what is a queue. So queue is a data structure where we have first in first order type of data retrieval. That is, the elements that are inserted in the queue first are the ones that gets deleted from the queue or that gets removed from the queue. So here there is only one difference between the normal queue and this one. So deletion is going to be same. So in a normal queue, so I'll write a normal queue like this. So in a normal queue, this is the front end and this is the rear end. Okay, so this is the front end where deletion happens. Okay, this is the front end where deletion happens. This is the rear end where insertion happens. Inserting new element happens here. Now only one difference, deletion happens in the front end only, whereas insertion doesn't happen in the rear end. It happens based on priority number. If there is a process which is supposed to be executed first, means it is of highest priority. Highest priority means priority number is going to be 1. So if the number is less, it means the priority is more. So we are going to insert it based on ascending order of the priority number. So this is same as, or this is a special case of ascending order linked list. So I will be creating next video based on this, which is ascending order singly linked list or doubly linked list, doesn't matter. So ascending order linked list. In ascending order linked list, the list that we create itself is going to be in a sorted order. How can that be done? So insertion, we don't have different options like in the previous program where we had done linked list. I had given 5 different options for insert. Inserting in the beginning, inserting in the end, inserting it at a given position, inserting after a given number, before a given number, all that we have done. So in ascending order linked list, what we are going to do is there is only one insert option. Okay, so only one insert option is going to be present, and that insert option is going to insert the elements based on its contents. So the same concept is used in priority queue, but the difference is in the priority queue, the item is different, priority number is different. So in the linked list that we have done so far, we had only one element, right? So we had a structure called node, which had one element, which was data. And then we had a pointer for the next element, right? Means we had only 2 fields. Now for a priority queue, we are going to have 3 fields. One is the priority number. So let us have one number as priority number and the number to be inserted. Based on the priority, insertion has to happen. Now how to do this? Deletion, as I told you, it is the same as the normal queue. Now how is the insertion is going to happen? So suppose we have different cases to consider. Suppose the list is empty or the queue is empty. Suppose queue is empty, then it means the head pointer or the first pointer is already null. Okay, so the first pointer is null. So we are going to just create a node and we will add the data and the priority, and the next pointer is going to be null, and we just store it here. So whatever is the priority, we are going to store it here. Let us assume the number that I insert is 30 and priority number is some 3 or something, and next is null. Okay, now the list has some number. Now next again I am going to give insert option. Now I will insert number 40 and priority number I will give 5. So if the priority number is 5, now it is on 5th priority, that is the meaning. Now we are going to check the queue. The queue content is not, queue is not empty, it has some contents. Since the queue has some content, now I am going to compare the priority number of the number to be inserted and the number that is existing in the queue. I will first create a node. Node will be created. Data is inserted. Priority number is also inserted. Now I need to attach this This is temp. Now this I need to attach to this queue. Should I attach it before or later or in between? So that is what I need to determine. Here the queue is not empty. Now what is there in this priority number 3? I'll compare that with this number. If the priority that is present in the queue is already lesser than this, if the number is less, means priority is more, right? 3 is lesser than 5 means priority is greater than 5. So this should be inserted after 3. So I'll keep executing it as long as next is not null. Okay, the next pointer should not be null. As long as the next node is not null, we will keep checking the priority of this node. Okay, so this we will assign to T. The priority of this next node and this one we keep checking. So this must be inserted before we get a number that is greater, that has a greater priority number than this. So here it is 3, next node is null. It means I am going to store this one here. So since it is next node is null, if I reach the next pointer as null and I have not reached a node where the priority number is greater than this, then I am going to attach it here. So this one is going to be stored here. Okay. We have 5 here, 40 and null, and this is having address of this node. Now the list contains 2 elements. Next I am going to insert a number 50 and the priority number is 2. So now again a node is created. Okay, node is created, 50 is inserted, 2 is also inserted. Now I have to compare, this is temp. Okay, so first I am going to compare what is the priority number in the first node and what is the priority number in the node that I need to insert. So this number is lesser, so this number should come before 3, right? So I am going to establish the new link, that is this link I am going to create it here, and then first pointer is going to point to this. So if priority number of this one is the new node is lesser than the first element, then this is similar to inserting in the beginning. So I'm going to call insert beginning function of our linked list and I'll pass this information. So it will take care of the insertion. Okay. So that is inserting in the beginning. Now next I am going to insert, say, number 100. Priority number is 4. Okay, I'll just rewrite this list. We have inserted number 50. Priority number is 2. Next node is this, and this is our first node. Okay, now I have to insert a number 4, number 100 whose priority number is 4. So I will create a node. Okay, I'll create a node, store this 100 here, 4 here. Now I have to insert it in this list. First I'll check whether first pointer's priority number is greater than this, or if this is lesser than this, then this should be inserted in the beginning. Now 4 is not less than 2, therefore inserting at the beginning is not required. So I am going to assign this to T and execute this code. As long as T next is not equal to null, means as long as I don't reach the end of the loop, I am going to keep checking. So what is that I check? I have already checked the priority of the node that is pointed by T, which is the first node's priority. I have already checked. I have to check what is the next node's priority. In T next is this node. Here what is the priority? I'll check. So in T next there is an element called priority. So I will check whether that number is greater than the temp's priority. Okay, if that number is greater than temp's priority, then I have to insert this number before 3. I can only insert a number before a given element because the previous node's pointer needs to be modified. So being in this node, I should check what is the priority of the next node. Now priority number of next node is not greater than this. Okay, it is 3, it is not greater. Therefore, we are not going to insert it here. We will just go to the next element, T equals to T next. So I'll move to the next pointer. Now I'll check t next not equal to null. Yes. Now I'll check whether t next priority is greater than temp's priority. Yes. Since this priority has a greater number, this node should come before the next node. So now establish temp next equals to t next, then t next equals to temp. That's it. So this is similar to inserting before a given element. So the element is the insertion procedure is similar to insert beginning and insert before, and these two we are going to combine and write one common insert function. We will copy insert at beginning also, and deleting the front element or deleting the first element is going to be the order. Okay, so delete will happen from here. So whatever is there in this point, that is going to be deleted. That is if the next pointer is null, so this number is going to be deleted. So this is the operations for priority queue. I mean, basically this is ascending order linked list and priority queue, both concept are same. In ascending order linked list, I will have only one element data. Based on that content, I am going to do the insert operation. In priority queue, I will have two element data and priority. Based on priorities ascending order, I am going to arrange this content. So go through this priority queue program and rewrite it, or write your own ascending order linked list program. Now for this is for pointer implementation or linked list implementation. For static implementation, it is even more easy. For static implementation, we are going to create a structure. We are going to create a structure called a priority queue. Here we will have two elements. One is priority and one is the data. Two elements we are going to have, and we will create an array of elements. Say struct priority queue. Okay. Struct priority queue. I am going to write queue 10 or 100, whatever you want, you write. Now I am creating a static implementation with 10 elements. So we will have an array here, and in the array we'll have two numbers, right? We'll have p as well as data, right? We'll have priority and data. So when we will have front and rear, both options are going to be present. So when we see a number that has a lesser priority than the existing number, we're going to push everything to the right and then insert it there. That's it. So we have to again, the order is similar, creating an ascending order linked list, and same concept we'll be using here. Here we are going to have a front end and a rear end. So this is front, this itself is rear, both are -1. Initially both front and rear are -1. So if it is -1 means queue is empty. If the queue is empty, both are made 0. Front is made 0, rear is made 0, and priority and the data is inserted at position 0. Next we are going to insert a number. So first we will check whether the priority number here is greater than the number to be inserted. If yes, then wherever is rear element, we are going to copy all the elements to its right position one by one, and we are going to store this number here. Okay, so right now let me take 50 and 4. So here we will have 4 is a priority and 50 is the data. Now here this is both are 0, both are at position 0. Next I am going to insert a number 100, and priority number is 5. Now priority number is not less, it is greater. Therefore R is incremented. F is going to be same, R is incremented, or rear end, no, rear is going to be same, front is incremented, and here we are going to store these numbers. Okay, next I am going to insert another number 90, and priority number is 8, and we keep checking until we get a number that is greater. Say for example, now I'll check 8 with 4. 8 is greater than 4, so I move next element, and 8 is again greater than 5, and that's it. We don't have any more elements. So this is incremented, and we store 8, 90 here. Next I want to insert a number whose priority number is 6. Okay, so I'm going to insert 60, and the priority number is 6. Now I'm going to compare it with 4. It is not lesser, right? 6 is greater than 4, so I move forward. and I'm going to check this number 6, which is greater, then it is 8. So 8 is greater than 6, or in other terms 6 is less than 8. I got a number whose priority number is greater than the number to be inserted. Now wherever front is, from that position onwards until this position, I want all the numbers to be moved to the right. Now there is only one number, so this we move it to the right, and this becomes 890. Next we are going to insert here. I'll take this as 7. Okay, 60 comma 7 comma 60. Next I'm going to insert a number which is 45 at priority number is 6. Now 6 is compared with 4, 6 is not less. Then I'll move forward. So say I'll have a variable called j. J initially I'll take it as 0. So this is 6 is not less than 4. Then I'll go forward, j is 1. And now at 1 I have 5. So 6 is not less than 5. So next j is made 2. Now 6 is less than the number at j, right? So j is 2 now. This is 0, this is 1, and this is 2. Now from f up to j, I am going to move all the numbers to one position to the right. So this is made f 8 comma 90, and next this is 7 comma 60, right? So that is copied here, 7 comma 60. So from f until j, all numbers are moved one position to the right, and at this position I am going to insert the number that is present, whatever I need to insert here. Okay, so we are just making a space for the other number, for the new number to be inserted. So for that, from the point where I got a priority number greater than the number to be inserted, until that point, from the last until that point, I am going to move all the elements to one position to the right. So I make a space here, and at this space I am going to insert the new number which is required. Okay, so this is for priority queue in terms of an array. Now how long you can do this is as long as f is not equal to size minus 1. If size is 10, we have only valid positions until 9. So as long as f is not equal to size minus 1, we are going to keep implementing this. Once we reach if f is 9, it means the queue is full. Insertion itself will not happen. If f is not 9, if f has not reached until the position 9, then we can keep inserting the elements based on the priority number. This is for static implementation. Now let us see how to do it using a Dev C++ software. I am opening linked list program, and I'll create a new source file. Okay, this is for implementation of priority queue. So implementing priority queue, I am going to copy most of the contents from here. What all things we need: header file inclusions, structure we need, that is node structure. Okay, instead of node, I am going to give it as a queue. Okay, I'm going to create it as queue. Insert beginning function is required. I will have this main switch case completely I'm copying, and with insert beginning, all this I'm copying. I will copy delete in the end. Delete end I'm going to copy. and I will copy display. If you have not attended the previous classes, make sure you go through linked list program. Linked list part 1 and part 2 is explained with all possible cases, and I have also mentioned in that video that in case you understand this, you have to take time to understand this, because almost all the programs, linked list programs that we are going to use, we will be including certain functions from the previous program. And we have display function. There's one more insert function that we need. So there are certain changes that are required here. Not just data, I want priority also to be stored. That is one additional thing, priority. This is your priority, okay? And when I'm inserting a node, insert beginning requires only one number. I'm going to have one more, okay, everywhere I need to change it as node. So what I'll do is I'll keep this as node only, so that I don't have to change it into queue everywhere, okay, right. So when I'm inserting, first I need to give insert node star int comma int. So first int is the data and second one is the priority. If priority is 1, then we are going to call insert beginning function. If priority is more than 1, then we will pass priority number also and call a different insert function. So in the options, we are going to have priority queue implementation. Priority queue implementation. So we have only insert option. Insert a new element is the only option. We don't have inserting at the end. All the other remaining options are not there. And delete also, we have only one delete option. Okay. Just delete option I'll give. And we are going to have display option. Search we can keep if we want. Let's have search option also. Not necessary. Okay, search option we are not going to have. Display contents. Display queue contents. These are the 3 options we have. So this is case 1, 2 and 3. And this is exit is 4th option. So case 1 is there, which is enter number to be inserted. Then we are going to take priority also. Priority is P. I will write printf, enter the priority. Whatever is entered, we are going to store it in number P. If priority is 1, that is if P is equal to 1, then we are going to call insert beginning function. So for this I will call, I will pass first parameter, pointer, and I will pass num variable. Okay, so this is if P is 1. Else, if P is not 1, then I am going to call the normal insert function, where I will have first num and P. So here insertion is done based on the value of P. It's actually going to be similar to insert before option. Okay, the code is similar to insert before. So case 2 is not there. Case 3, all these things not there. We will have deleting end element first, and name of the function is just delete. It's just delete. Okay, and there is no other delete options. There is no search option also. Next is display option, and that is option number 3. I'm having display here. Then we have 4th option. 4th option is end of priority queue program. End of priority queue program. Then default is enter valid choice. As long as choice is not equal to 4, we are going to execute this program. Hope it is clear. Now I have all the functions mentioned here. One is insert function, one is delete function. If the priority number is 1 or if the priority number is less than, okay, I don't want to give insert beginning here. We'll just call insert function. We will just call insert function here because it need not be 1 even if it is some other number. If it is less than the first number, we have to call insert beginning only. So we're going to call insert function. There we will decide whether we have to decide it in the insert it in the beginning or somewhere in the middle. So that is insert function, delete function, then we have display, and that's it. Now insert beginning option is there here, and in insert beginning function nothing needs to be changed except priority number. Here we have priority also, so we need priority also to be included here. Int p, we need priority as well. Here I'll change int. For inserting at the beginning, we are going to just add just one more code, that's it. So along with the data, we have priority also now. That is the only change we need. Temp priority is equal to p. That is the only change required. Nothing else is required here. Then deleting in the end. So name of this function is delete, right? And whatever is in the end, list empty, I'm going to give it as queue empty. Whatever is in the end, that will be deleted. Nothing to change in this function. Next is display. Display function also nothing needs to be changed. Let us put one more data also. %d, %d/n. Okay. So I'm going to write temp data and temp priority also. Okay, that is in display. Now let us write the program for insert. Node star insert node star first. So only this function we are going to write freshly. Int num, num, let it be num, int p. Now first we will have two pointers here. One is to store the number, store the node that we are going to freshly create. One more is to navigate through the list. Now we will create memory because anyways we are going to insert. So there is no point of not insertion not happening is not a case. So we are going to assign value. Node star malloc size of node. Okay, now we have to insert both the data. Temp data is equal to, okay, so before doing this we are going to check if first not equal to null. I will check if first equal to null. Okay, if first is null means the list is empty, queue is empty, therefore whatever number I am going to insert, that is going to be the first element. So it is same as insert beginning function. So I will call insert beginning function by passing all these parameters. First num p. If list is not empty, else if, so if list is empty, if queue is empty, we have to insert in the beginning. And also suppose the first element's priority number is greater than this p, then also we have to insert it in the beginning. So that condition also I am going to check separately. If first priority is greater than p, okay, so the number that is there in first priority, if it is greater than or equal to p, only if it is greater than p I am going to store it. If it is equal, we will store it next. Okay, first is equal to insert beginning first num comma p. Okay, So what is this? If the queue is empty, we are going to execute the code which is inserting at the beginning. Suppose the queue is not empty, I am checking whether the element in the first position has some priority number. If that number is greater than this number p, means this element should come first. So again I am going to call insert beginning function only. Suppose the first element has a number that is less than p, it means this number is going to be somewhere in the middle of the queue or towards the end of the queue, which is what we are going to check. If both this doesn't work, then we have the code to insert. Now here I'll create memory. If the first two conditions are satisfied, then memory is created inside those functions. So that's why I have not written this malloc code in the beginning. Temp data equals to num, temp priority equals to p. These two elements I have inserted. Next I need, so first element is not equal to t equals to first element's priority is not greater than is not less number than the given one, so that is for sure. So now I am going to assign t equals to first. So how long this needs to be executed? While t next not equal to null. Okay, as long as t next element not equal to null, we have to keep checking this. If t next priority is greater than p, okay, if the next element of the present node in the next node, if I have a priority number whose value is greater than the number to be inserted, then I have to insert the node at this position, otherwise I have to just move forward. Okay, so if it is greater, then in that position we have to insert it. So temp next is equal to t next, and t next is equal to temp. That's it. So this piece of code will make sure that the element is inserted at that position. Okay, so right now we are in some node t. There is a next node which has a bigger number as priority. So in between these two nodes, the new temp node must come. So temp next is equal to present t next. Then the present t should point, its next pointer should point to the newly created temp node. As simple as that. Now the new element is inserted. Else, suppose the next element is not greater, then we just move to next pointer. And after insertion, we just break the loop. Okay. Now when we come out of the loop, so I'm going to come out of the loop under two cases. One is I might have reached the end of the loop, I have not inserted, or I might have inserted in the beginning and I have used this break statement. I might have come out of the loop. So I need to check how I have come out of the loop. If I have come out of the loop because the next pointer was null, means my element is going to be the end element. In that case, that is, if t next is equal to null, means insertion has not happened actually. So in this case, I have to insert temp pointer there, and temp next I am going to give it as null. So this should be executed if I have reached the end of the loop. Then the last node's next pointer should now point to the temp node, and temp's next pointer is going to be null. That's it. So that is the code for inserting at the beginning, and this is for which bracket. This is for node, and the last one is extra. Let us check the program for any errors. Hopefully, okay, good, there are no errors. Now let's check whether the program is executing properly. Priority queue implementation, we have only 4 options. First, I'll check third option, that is displaying elements. It says list is empty. Let us modify it to queue is empty later. Now I'll check delete option. It says queue empty, deletion failed. Good. So we go for the first option, inserting a new element. Now number to be inserted, I'll give 30. Priority number, I'll give 3. So insertion is successful. Now I am going to display the contents. 30 and priority number is 3. Let me insert the numbers in multiple so that it's easy for me to remember. I'll again give first option, or now I'll give delete option. Enter choice 2. Okay, it is deleted. Let's see. Yeah, list is empty. So deletion has happened properly. So I'll give number 30, priority is 3. Okay. Now I'll give display 30 and 3. Now again I'll give number 1. Number to be inserted is 50 and I'll give priority number 5. Let us display the contents. Okay, so 50 and 5 has come. So 30 and 3 is not there. So basically if we first option enter number to be inserted, I'll give 10 and 1. So 10, 1, 55. So inserting in the beginning is happening properly. Inserting in the end so inserting in the end is not happening properly. So let me change it. We have to return, no? Maybe return function is not working. Yeah, there is no return function. I have not returned anything. That is the reason. So these two functions will return the values. After this, I have to return first. So that's why it was not working. Now let me check. So that is the reason I always keep telling whenever you run the program, make sure you check all the possibilities. Now list is empty, list is queue empty, deletion failed. Option 1 I'll give 30 and 3. Now I'll display the contents. It is 30 and 3. Again option 1 I'll give 50 and 5. Now we'll display the contents 33, 55. Yes, now I'll give one more number 70. Priority number I'll give 7. And now I'll give 10. Priority number is 1. Insertion successful. Now I will give option 1 40. Priority number I'll give 4. Now again we will display. Yes, so insertion is happening properly. Now if I give deletion, it is going to happen from the first element only, that is deleting at the end only. So therefore delete option is going to remove 70 and 7. Okay, so the remaining elements are intact. So based on highest priority number, it is going to remove. So here the priority number is 1, no? So then 1 with highest priority should be removed. Therefore delete in the end is not the option. We have to give delete in the beginning option. Okay, so this the entire program is correct, but we have chosen a wrong delete function because this is a priority queue. Insertion is done based on priority number. Deletion should also be done based on priority number, right? So whatever is of first priority, that work needs to be completed and removed from the queue. So here delete beginning function we need to use, not delete end function. So that is the only change required. Now let's change that and that will complete the program. So let me delete this one, and from linked list program I am going to copy delete beginning option, delete beginning function. Where is delete beginning? Yeah, delete beginning function is the one that needs to be deleted. And we'll change the name of the function to delete. Whatever is there in the beginning, that needs to be deleted. Nothing needs to be changed. Instead of empty list, we will put empty queue. That's all. In display also, we will write queue is empty. That's it. I'm going to check only the delete function. For that I'll insert some elements. 30 and 3, 50 and 5, 20 and 2, so these are the numbers. Now if I use delete option, the process which is of first priority, that needs to be processed and removed from the queue, means 10 and 1 should be removed from the queue. So deletion is done. Now we will display See, 10 and 1 is removed, remaining elements are present. Done. So this is our priority queue implementation using linked list. So I've explained how to implement a priority queue using arrays. Program for the same will be shared in the Telegram channel. So if you have not yet joined the Telegram channel, make sure you join our WhatsApp group and also the Telegram channel, where you will get all the resources, all these notes you will get there. Okay, so if you have understood this, then make sure you share this video along with your other classmates also, and keep watching regularly for updates on C programming and data structure upcoming videos. We are planning to start a new subject as well, so let us know in the comments what you want us to start, C++ or Java or Python. So tell one among these three, and SQL also is there in the list, so you can inform what is required more. So we're going to start with that, and then we will proceed with the remaining subjects as well. Okay, see you in the next video. Take care. Bye bye.